Okay, good morning, everybody. We will continue in the things we were learning that was from chapter number 10, and it is about the beam analysis. And we have the differential equation e to power 4 into y dx4, right, minus dx is equal to 0. Yeah. And along with that, we have the boundary condition.
Sir,
Yeah, and those boundary
sir,
conditions. All right.
sir. Hello, sir.
Somebody asking anything?
Yes, sir. Sir,
Yeah, yeah.
this sir screen is not completely visible. Blackboard is not completely visible.
Oh, so the shining, is it?
No, sir. On the right hand side.
No, it's visible. You you just click and do it. You pin it.
Yes, sir. I have done that, but I could not see the complete equation on the screen.
Okay, so it's shining as well. Okay, I will try this side then. Okay. And that's why you should come here, man. What happened?
Sir, actually, I was not well today.
Huh?
I was not well today.
Achha. Chalo, we will do from here.
Yes,
You see it?
yes, sir. Here it is.
Okay. So maybe little bit this side. Now you tell me, is it fine from here?
Yes, sir.
Okay, so we have the beam equation, the 4 uy over the x4 minus dx is equal to 0. Yeah. And we have the boundary conditions. Boundary conditions will be what? So you have a beam. Let us say you have a beam here, and which all things you can give? You can give 4 things. Which all 4 things? You can give a displacement here. You can give displacement there. You can give force here. You can give force there. But 4 things means each point will have 4 things. Yeah. So you give 1, node 1, node 2, you call it. But degree of freedom wise, degree of freedom 1, degree of freedom 2, degree of freedom 3, degree of freedom 4. And each degree of freedom has 2 things, either displacement or and. So there are 8 ways. Actually, boundary conditions, if you see, 4 you have to give, 4 you can get. Right? So 4 boundary conditions. Right? 4 way to give. So either you can give one of uy1 and what? b1. Either this or that you have to give, right? So you give for this is either u y. So this is uy1. This is theta1, right? This is uy2. This is node. It's a node 1, node 2, right? uy2, and this is theta2. So these are displacement. So either uy1 or v1. v1 means force. This is equivalent. This is the displacement that it shares, and equivalent we can draw for forces. So either force is given v1, force is given v2, and moment is given n1. Yeah. So either this or that is given. right? Similarly, either, so I'm going to write accordingly, either theta1 or m1 is given, either uy2 or v2 is given, either theta2 or m2 is given. Yeah. Okay. You have one of these prescribed. Yeah. So but you cannot give both. It's not that you give uy1 and v1 as well. It's not possible. As we have seen earlier also, right? So either you give displacement or force, but not both. Remember, right? So we have that. Now today, what we'll do is we are going to find out the the usual way of solving a finite element problem, right? And how you do the first thing you do is, this is a strong form. A strong form is basically the differential equation along with the boundary conditions. In order to apply the usual approximate methods, right? Galerkin method, for example, Rees method. What do? First, you have to get the weak form. So first we have to find out what is a weak form, and from there we solve, right? So usual method that you have to adopt will be like that. So what is the weak form of that? So as usual, what you do? d4 dy over dx4 minus. Is this correct here? I think you also have ei here. Right, so you have ei. Yeah. Actually, this if ei is constant, it should be something like d square x square, then ei d square uy over dx minus px equal to 0. Why? Because what you got earlier, remember, this is nothing but m. So you got d square dx square minus px equal to 0. Here m you got it as ei, right? Remember, dy over dx square. Right? If you see our derivation, we got like this, right? So this is how we got, and their m itself is given by this. Yeah, you remember? Okay, so we put it here. So actually the equation is like this. When vi is constant, then goes outside. Okay, now, so this big form, this one is, we can multiply by a w. Now w itself is, will have the same dimension as the displacement. Right? So here you have uy, it will have same property as uy, and then w multiplied by d square dx square ei d square uy over dx square, right, minus dx dx, and all of them will be equal to 0. Yeah. Okay. And this will be, so if the length is from here to here L, so of course you have to Or make it. Okay. What is P? Px is the forces that you have distributed load. So it's Newton per meter kind of load. Once you have that, you will write it as, you will expand, say, or W P square over dx square Pi P square Uy over dx square, right? Then you have x minus 0 to L W is a function of x, of course, and then times dx and dx. Okay. Okay. Once we have that, we have two terms, so we can have one at a time. Oh, this one is straightforward, multiply by W. So let's call this one where we will expand this 0 to L W P square dx square Pi P square Uy over dx square dx. Okay, now integration by part. Remember, we have seen that we apply integration by parts and we get the what we want. Yeah. So it will be equal to you can visualize this way, 0 to L W, and then we have d over dx, and then you have what? D over dx again, right? And then you have Ei, p square Uy over dx square, right? Fine. And then you have dx. So, like this. You agree? Why we did? Because here
Sir,
dx here. Yeah.
sir, sir,
Yeah.
sir, screen is not going till that side. Sir, screen is not going till that side.
Man, did you tag it like not tag
Yes,
but the pinning it?
yes, sir, I have done that.
I did more. That's why. But nobody complained earlier, man. How come you are complaining? Yeah. हाँ बाकी लोग को दिख रहा है.
पता नहीं sir.
शुभम.
Yes, sir, I have pinned, but still, it is going just somewhere away from the screen.
नहीं बाकी को तो प्रॉब्लम नहीं हो रहा है ना. I will not get a space basically, कहाँ तक जाता है बताओ.
हाँ sir, यहाँ तक ठीक.
Up here.
No sir, just a little bit on left.
Is it fine here?
No sir.
Here?
Yes sir.
ठीक है अब.
Yes sir.
मेरा ब्लैक बोर्ड तुम छोटा कर दिए. Okay, you will come to the class, man. Okay, get well soon.
Yes sir.
Okay, so once you have this one, then we are going to, as I wrote earlier, you will simplify it as W P over dx, again d over dx, and you will write I E square Uy over dx square Yeah. So we have this, and then we have this. Okay. So what I did, this I divided into two parts. So d over dx here, multiplied by d over dx of this and like that. Why? Because now we can do integration by part easily. Yeah. So you know that you know the trick, right? You have dx here, dx here. This is in a way you have w times d of this. The whole thing. So you have is equal to what do you write? You will have w then multiplied by this, multiplied by d over dx and ei, right? So this whole thing, right? So d over d ei d square uy over dx square, right? This whole thing you have, and this you will have from the 0, right? Just smaller, and then you will have minus, then what? Right. So then you will have 0 to L d w over dx multiplied by this one, right? Multiplied by, you get this now, right? So multiplied by d over dx, and then you have ei d square uy over dx square, which is m. We can also write it as m actually. So this is nothing but m, right? Okay, is equal to this, is equal to this, is equal to this, yeah, is equal to, we can also write in terms of w multiplied by, what is this value? This is dm over dx, right? L 0, because this is m, yeah, and here you have to minus 0 to L and dw over dx multiplied by dm over dx, right? Also you can write like, okay, now we will go further. Okay, done. Now we'll say, what is the meaning of dm over dx? Minus what? Minus alpha minus v, right? Because it's shear force minus v. Okay, so you can also put that here actually, right? So you can, the first one, so that really means w times dm over dx. L 0 is equal to minus of w times v, right? Now next thing, this we will put there, but also we have there dw over dx, dm over dx, dx 0 to L is equal to, yeah. Now integration by parts again we will apply twice in this case. Why twice? Because we have d to power 4, so we have to make such a way that w have the same derivative, order of derivative as u, right? So in order doing that, we are going to do that. So integration by parts again, and then what you get? You get dw over dx multiplied by m, and then you have L 0, and then minus 0 to L, and then what do you get? D square W over dx square multiplied by M. Right? Okay. Now sum it up. Here we have this equal to this. Remember, we start from the big foundation, the whole thing equal to 0. Where this is equal to the whole thing, where this is equal to given there, this is equal to. So we'll write this equation. So let's call this equation number 1. Rewriting equation number 1. So equation 1, right? The whole thing here, this is equal to this thing, where this is equal to W. So we write first W multiplied minus V, right? So minus W V L to 0, right? This is what? This one, right? Then minus this thing. So minus this whole thing. This whole thing is this guy, right? So we have this d w over dx m L to 0 minus 0 to L d square w over dx square m x, right? Bracket 1. Okay, so here what you see here, the whole thing, this simplified version, we are writing it here. Then the other thing, we have minus, then the whole integration. The whole integration is given by this guy. Okay, so we are writing that. Okay, so this is complete. Then you have minus 0 to L E x, right? Wx first, dx, dx, and is equal to. Okay. This is the whole thing that we got. Any question, guys, so far? Okay. Expand further, we say or minus w, which is a function of x, just write this. V will be also a function of x, right? So this is at L 0, minus dw over dx m function of x. This is also L to 0. Let me delete that side also. Then plus 0 to L d square w over dx square, and then you have m dx, and then you have minus of this, minus 0 to L wx multiplied by dx equal to, yeah, everything all right? Or we write 0 to L d square w over dx square, m full form we write ei d square uy over dx square dx, because m is equal to ei d square uy over dx square, so we write it here, right? And all other things take it the other side. This will be equal to w x dx L to 0 minus dw over dx mx L to 0, sorry, plus, yeah, then plus 0 to L wx dx, right? Yeah. Huh? Say again. Where 0 will not be there. Oh yeah, yeah. What you see here is this whole thing. If you see, all have form, but like air forces. Here you have. Finally, the idea is the whole this thing you will convert into a times u, and this whole thing you are going to find out here. But of course, you will have a w which is coming here, right? So you will have w transpose f, right? And then we get rid of w, we get k equal to it. That's the whole. But this is the weak form, and we are going to expand this side, the other side. We can say equal to is equal to, you have w at L multiplied by v at L minus w at 0, v at 0 plus dw over dx mx dw over dx x equal to L m L, right, minus dw over dx at x equal to 0 m at 0, right, plus 0 to L wx dx. Yeah. Now, what is property of w? So Wx is equal to 0, where uy is given. Right? Similarly, dw over dx is equal to 0, where duy over dx, that is theta. Where theta equal to duy over dx is, yeah. So you can apply that. If, let us say, if u is given here at uy is given at L, then this whole thing will be 0, and so on. So this is the property. Also, the theta also is the same way. So here W is a expression where you have 2 degrees of freedom. One is uy and derivative of uy as well. That's the theta. If you have both of them given, then both W and derivative of W at that point will be equal to 0. And so accordingly, you understand how to apply the boundary condition. Yeah. So this is what the, you will say this equal to this for all W, right? Such that yeah. So this is complete. This is equal to this is the big form for all W's such that Wx equal to 0 where uy is given, dw over dx equal to 0 where theta is given. That's the only thing is, next thing is to how to solve them. Right? Any questions so far? Okay. Next thing is the shape functions and all, because we want to find out what is the test function. Right? So test function. Meaning that we have a beam element or beam element. And how does the beam element look like? Beam element will have 4 degrees of freedom, as we have done earlier. There will be node number 1, node number 2, and the element number, if there is a beam, for example, if you have a beam here, and there is some, maybe it's loaded here, then it's loaded here, right? And maybe at here, right? All kind of things are possible. How will you solve it? You will first divide into a number of elements, right? So you will have number of elements. You will give a number, node 1, 2, 3, 4, 5, 6, and so on. Element number 1, 2, 3, 4, 5, and then you will assemble it the way you have been doing, right? Assembling degree of freedom, you have to look at same degree of freedom should go one place, and so on. Your method. So basically, now we have to look at, this is the global node numbering. The local one will be 1, 2. So we'll take 2 noted beam elements, which is node number 1, node number 2, and you have uy degree of freedom here, right? uy1, which is given theta 1 is given, uy2 is given, theta 2 is given, and we have to find out the, first we have to say test function, right? That's what we're talking about. Test function uy1 is equal to, it will be such a way, how will we write? We will equal to n1, right, not like this, but how do we write? We write n1, right, multiplied by u. So you have n1 times uy1 plus, so this will be n1, which is the function of x, uy1 plus n2x times theta 1 plus n3x, right, times theta 2, uy2 plus n4. N4 is this, right? So degree of freedom here 1, right? This is 2, this is 3, this is 4. So n4x times theta. Yeah. uy1 is not like that. This will be like this. uy and yeah. Is it correct, guys? Earlier we have to, okay. Earlier, if you remember how we did, so you had here n1 here n2 here, right? So you have like going like this, right? So you say x ux is equal to, right? So you say ux, this is uy. So this is defining for the whole thing. It is not just for one place. You are defining for the whole thing. The way you did ux, or you remember for 1D problem, you said n1 u1 plus n2 u2. So this is only one equation that defines the uy for the whole thing, right? For what? For x 0 to l. It's defined for all of it. So this is how you define uy x equal to this. Simply. From here we get everything. The single equation, single displacement that you think will be a good candidate, right? So you call it a test function because you're going to test whether this will work or not. So you are going to write that. That means there will be 4 shape functions. What is the property of n1, n2, n3, and n4? You can see that uy1 becomes uy1 is where? X equal to 0. If you put x equal to 0, the n1 0, n2 0, n3 0, n4 0. All should be 0 except n1, which should be 1. Right? Since uyx equal to 0 is equal to uy1, that tells you that n1 0 equal to 1, n2 0 is equal to 0, n3 0 is equal to 0, n4 0 equal to, right? This is the property, right? Now what? Second thing, this n2x times theta 1. This we have to take care. So how will you do it? What is theta? If uy is given as this, what will be the theta? Derivative of that. Theta x will be equal to duy over dx. Will be equal to dn1 over dx uy1 plus dn2 dx theta 1 plus dn3 over dx uy2 plus dn3 n4 dx theta 2 is equal to 0. Right? You get something out of it, and what you get? Theta at 0 is equal to theta 1. Right? Is that equal to like this, right? If theta 1, that really means what? dn1 over dx is equal to 0. dn2 over dx has to equal to 1. dn3 over dx is equal to 0. dn4 over dx is equal to, yeah? Got it? Okay. Similarly, u y at x equal to L is equal to uy2, and that tells you that n1L is equal to 0, n2L is equal to 0, n3L is equal to 1, and n4L is equal to 0. Similarly, theta at x equal to L is equal to theta 2. That tells you dn1 over dx, x equal to L is 0, dn2 over dx, right? dn2 over dx at x equal to L is equal to 0, dn3 over dx, x equal to L is equal to 0, and dn4 at over dx, x equal to L is equal to 0. These are the properties, and we have to find out accordingly. So how do you find? You want to find out n1. So look at the property of n1. n1 property of n, for example, property of n1x. And what is that? This n1x is n1 0 is equal to 1, right? The n1 over dx at x equal to 0 is equal to n1L is equal to 0, and dn1 over dx x equal to L. Yeah. Okay. Now there are 4 boundary conditions, and you want to represent n1 as a polynomial. What kind of What will be the order of polynomial? Order. N1x will be something like alpha will be cubic, will be alpha plus beta x plus gamma x square plus delta. You have 4 coefficients to find out, and you have 4 equations, right? You get 4 equations. You put 0 here, you can find out. Okay? Similarly, you have to repeat for all of n's. There are 4 n's. Also, we can see the property. N10, it has a root, as if you see here, it has double root. N1 L is equal to 0, N1 at L equal to 0, and also dn derivative of N1 is also 0, right? That means it has a double root. That means another way of looking at it, N1x will have some, let us say, some constant c. It has double root here, where at x equal to L. So this will be x minus L square of it, right? So that even if you take derivative, there will be x minus L left, and hence x equal to L makes it 0. Hence it has double derivative. I mean, it has repeated root, so it will have a square of it. And then we don't know. Now this is quadratic. Only thing we have here is a linear one, right? So that we make it cubic. And c is already there, so we can write as x plus some value. Let's call it c. Let's call it d. For derivative, so let's call it some other value. Let's call it a. A is not there anywhere, right? So let's. Yeah. Now, only thing is we have to find out what is C, what is A, and we are good to go, right? So that's what we will do now. Quickly. Yeah.
For defining N1, we need to have 4 constants because there are 4 non-constants. So it's a cubic equation. But in the weak form, it is double derivative. So d square equal by dx square. So in that case, we won't get the constant instead we look at as a function of x because of that one increase because of the cubic.
Yeah. So you are left with a line, linear term, right? You have d square term, right? And you have uy, which is a cubic. So then you get a linear term there. D square uy over dx square will be a linear term. Because this is cubic, no? If this is cubic, if you take double derivative of this one, you are, what is remaining is a linear term which is remaining. Right? It's fine? Okay, so it will not be a constant term. It will be a linear term. Okay, so we have this. Now N1, what do we have? N1 x is equal to c x minus L square and x plus a. So of course, if you put x equal to L, this you get N1 L equal to 0. Take double derivative, you will get this also. Because you have, only thing we have to satisfy is this. N1 0 is equal to 1 is equal to c is equal to 0 minus L square 0 plus a. This is equal to minus CL square A, which is equal to 1. So you get this equation, so that what means C times A is equal to 1 over L square. Now next is derivative of that we have to take. dn1 over dx is equal to what you get. You have C, then you have 2 multiplied by x minus L, x plus A plus C x minus L square. That's it, right? So which is equal to x minus L will be outside. But doesn't matter, we can just put the values. So dn1 over dx at x equal to 0, which has to be equal to 0, which is equal to 2c, 0 here, so minus L, 0 here, you have A plus, right, C minus L square is equal to minus 2, right, minus 2 L C A minus 2 L C A plus C L square from square of it. So CA is 1 over L square is equal to minus 2L. This is 1 over L square. So 1 over L square plus CL square equal to 0. Or what you get from here? You have minus 2 over L, right? Plus CL square equal to 0. Or L square is equal, or C is equal to 2 over L multiplied by 1 over L square equal to 2 over L cube. Right? So you got that? And hence A is equal to 1 over L square multiplied by 1 over C. So you have L cube over 2 is equal to L over 2. Right? And hence you get the value in 1 x is equal to, you get C, which is equal to 2 over L cube multiplied by x minus L square, and then you have x plus L over 2. Right? So this is how you can do it. Similarly, you have to repeat for all the remaining 3. Yeah, you have to find. Or n1x is equal to, we now take multiply 2 here, so we get 1 over L cube, and you have x minus L square, and 2 multiplies here, so becomes 2x, and then you have L, right? So this is how it looks like. Similarly, find out n2x, n3x, and any question? We will see next time. Okay, what are the values of this, and proceed from there. Okay. Any question, guys? Okay. If there is no question, see you guys on Tuesday, 11 o'clock. Okay. Yeah. Not on Monday, but on Tuesday. Also, I will post the homework so that you can do on this weekend. Yeah. By when? I don't know. Maybe by Saturday tomorrow, probably. And I will give you sufficient time for it. Okay. Also, reminder that you have also a project. Yeah. So I hope you are working on those projects. They are important. Remember, guys. Yeah. So that decides even like one grade, it can go up. Because of it. So always do it. Sometimes it's a matter of also whether somebody is passing or failing. So this is by design to help you. Remember that, okay? And but do not copy anything from anywhere. Okay? Marks is also given for the complexity of the problem. So you read the document. Okay, so whatever was shared with you, you read it and follow everything. And so I'm telling from experience that students don't read it. So if you do that, you will get less marks. Yeah. Okay. Okay, guys. See you on Tuesday then at 11 o'clock.